Hi everyone and welcome to this video. I'm quite excited about this video because I think I found something quite special. So anyway, I'll tell you the story to start with. A company called Rayax got in touch with me a couple of weeks ago and they said, you know, we like the channel, would you like to try out any of our products? So I emailed back, yeah, of course. So they sent me these products and they arrived in a couple of days, which is really impressive actually for these companies, because they don't usually do that. Usually you have to wait about 4 weeks or so. Anyway, so they sent me these products, and here we go, we have the product. It's called Rayax RY-LR890. And these are transceivers. They're RF transceivers, so radio frequency transceivers. And for those of you who are quite new to this, a transceiver is a receiver and a transmitter in one unit. And I tried them out, and I'm very, very impressed. But anyway, let's look into the product, and I'll explain in more depth. Okay, so this is a 915 MHz LoRa transceiver. So let's have a quick look at it to start with, and then we'll go from there. So there's something that impressed me to start with, and that's the quality of the build. So if we have a quick look, I'll bring it closer to the camera. Take a look at the quality of the PCB. I think that's really good quality. And if you look at the back, if I can just get this to focus nicely, you can see that not only is the PCB very well built, you can see that it's gold plated and the precision is really good. So straight away I had very good impressions, mainly because of, you know, I was initially impressed with the speed of the postage. Secondly, I was impressed by the quality of the PCB, and then I got thinking, wow, this actually is an exciting module to test, because I assume that the quality of the you know, the transmission and reception will be really good too. Anyway, let's move on and identify all the components. We've got a helical antenna, which is pretty standard really. We've got a CAN, and presumably that's got their chip inside, their transceiver chip. And if you notice, there's something very strange about this transceiver. And if I just bring it closer to the camera, you can see what I'm talking about. If this is going to focus, it might focus, there we go. You can see that it says STM32L, and that's a microcontroller. So when I noticed that, I was thinking, well, why would there be a microcontroller on this module? Basically what happens is the transceiver chip there is managed by the microcontroller on here. So when you connect this to an Arduino, you don't actually connect to the transceiver, you connect to the chip which controls the transceiver. And what it means is that it makes the whole thing a lot simpler and a lot better really. So instead of interacting directly with that, you interact with the chip, which deals with everything for you. It's really simple. Now what's even more cool about this module is the pinout. So if I look at the pinout, you can see that this is also quite peculiar. So you can see here it says ground, nothing, TXT, RXT, NRST and VDD. And of course ground is ground, VDD is plus voltage, which is plus 3.3 in this case. And you can see you've got TXT, RXT and NRST. So forget NRST because I won't be doing anything with that. But we've got TXT and RXT. And that's really cool because this is a serial device. It's a serial transceiver. And essentially what you do is you connect your Arduino, but instead of having to faff about with libraries and all that sort of stuff, you simply send it what you want to transmit via serial. So you connect your Arduino up to the serial pins, so from Arduino TXT to RXT of this, and then you send the message via serial, and this simply transmits it for you. The microcontroller does everything, and then when it receives something, it transmits out of the pin, and that's really, really cool. So yeah, I've got the two of these, and there we go. Okay, so now I'm going to tell you what I'm going to do in these videos. So in this little series there's going to be 2 to 3 videos, and the first thing I'm going to do is go through documentation and find out how this thing works and show you, and it's actually really good. The second thing that I'll do is make a test rig, and the testing rig will be Arduino based. So this one's going to have an Arduino and this one's going to have an Arduino. I'm going to put one place, one the other place, and we'll do a range test. So of course the range test doesn't only show range, it kind of shows how reliable they are and how easy they are to work with, and that's it, and we'll see. I've got a little secret to tell you though. I've actually already done this. I've already planned it, as I do with a lot of my videos, and I can tell you I'm excited about this video. And the range of these is really, really good. Anyway, first things first, we'll go through the documentation. Okay, so I've printed the documentation out, and this is another thing. I'm really, really impressed with this company, Rayax. I get companies asking me to test products all the time, but this one genuinely is really good. Anyway, let's get on with it. So it says OYLR896 UART interface, and then it says 915 MHz LoRa antenna transceiver module, and it says here the transceiver module feature the LoRa long range modem that provides ultra long range spread spectrum communication and high interface immunity whilst minimizing current consumption. And like I said, I've actually tried this out, and you're in for a treat. So the highlights, in fact the highlights aren't particularly interesting. Semtex, yeah, whatever, excellent blocking immunity, low receive current, high sensitivity, control easily by AT commands. Now this is interesting. I find this very interesting. I've given these AT commands a go, and they're really good. Then I don't know what that means. Designed with PCB integrated antenna. Now PCB integrated, it's not PCB integrated, it's a helical external antenna, but whatever. And I think there is a different version as well, maybe. But anyway, so applications, Internet of Things, mobile equipment, home security, industrial monitoring, blah blah blah, car alarm. And then if we have a look at it over here, we can look at the pinout, which of course VDD is power supply, reset, active low, UART, data input, TXD, UART, data output. Now, I've not mentioned this, but these are serial devices. Serial. So they're not I2C, they're not SPI, they're not anything like that. They're serial. So this microcontroller here communicates with your microcontroller via serial, and I find that really interesting, and it's really robust. Anyway, let's carry on. So yeah, UART, RxD, TXD. It's so easy. And ground, and there's an image of it there. LED and resistor, it says. I don't remember seeing an LED, but maybe there is. On the next page, yeah, I'm not particularly bothered about that. I thought I'd just show you anyway. There's some specs there, but again, the specs don't mean a great deal to me. I'm not particularly interested in all that sort of stuff. And then here we go, there's just one or two documents which my printer doesn't seem to like very much because it's a laser printer, and I've just changed the toner. Anyway, so that's the documentation, or part of the documentation. Now this is the really cool thing. With these modules, these two modules, I'll just put them in sight, you get good documentation, and usually with modules, particularly the cheap ones you get on eBay, if you get documentation, it's usually very poor. That's not the case with these modules, although they are a little bit more expensive, but they are very good quality. So now I'm going to show you about the AT commands, and maybe you'll find this a little bit strange, but it's the way it is. So, LoRa AT command guide, and the way this works is that you actually configure these two, well, however many you have, you configure them via serial, or you can configure them via serial. So if you were to get an Arduino serial monitor up, or any serial monitor, and you were to give them AT commands, you configure the things. And maybe I'll show you that in a second. But anyway, let's go through this to start with. So I'm not going to go in extreme depth with this, but I'm going to highlight a few things to you. So it says AT command set. So let's assume now we're in the Arduino console, and you know the little box at the top where you can type in commands? We're there, right? So if you type in AT in capitals and press enter, it will respond with OK. And then there are different things here. AT reset resets the device. Then we've got the mode, which I'm not particularly interested in. IPR, which is the baud rate. Now I've left most of these at default because default works best for me. But look, you've got all sorts of different things that you can configure here. The band, again, I don't bother with that. Now, address. So this is where we kind of get started. If we want to test these two, they need to have different addresses, of course. So one of them can be address 0 and the other one can be address 1. So what I'll need to do, I've actually already done it, but I'll probably show you again in a minute. We'll need to set the addresses of these to 0 and 1. And all you do is you of course connect to it via one of these, which is a USB to TTL converter, and you would send over these commands. So AT plus address equals 0, AT plus address equals 1 to the other one. And the network ID, it defaults to 0 anyway, so considering I've only got 2 and they're on the same network, 0 works fine for me. Then let's carry on. ATCPIN, I didn't bother with that. It's an AES128 password. I mean, you can password protect your communication. That's really good. Then we've got some RF power. We can mess about with the power. Now, what's the default? It does. There you go, 15 dBm default. So, yeah, that's interesting. Well, let's carry on. Now, AT send. So, this is the important stuff, of course, and we'll need to use this in a minute in order to test. So, AT send, and the parameters you give it are the address. So obviously, if one's 0, let's say the transmitter's 0 and the receiver's 1, then to transmit from here to here, you'd say address 1, the payload length, which is the amount of characters basically, because it's serial, and then data is the text. Literally, it's that easy. And then, as an example over here, it says AT plus send equals 50, which is the address you want to send it to, 5, which is the payload length, and hello. And then, when it receives it receives a string like this, plus RCV, blah blah blah. And then we've got version, which I won't, I'm not too bothered about. And then a factory reset. And in this one you've also got the error result codes, which is really cool. Like I said, I'm not familiar with Chinese documentation that is this good. I don't think I've ever seen documentation that is this good for for modules. Anyway, so that's that. Now, let's put these back in view. So what are we going to do next?